I currently work as a developer advocate for K6.io and Grafana Labs, but I've always really been a software tester. I've been doing software testing for 10 years, and developer advocacy is something new that I've just, tried recently. So today, I really want to talk to you about, what a hybrid approach to performance testing is, like, why we need to do both backend and performance testing, and really what is this hybrid approach. So first off, if you want links to the slide, just take a picture of this QR code, and you should be able to have, copies of the slide. But if not, I'm also happy to just provide the link via like the chat functionality once I am finished. So first of all, when it comes to creating a performance testing strategy, teams normally have the option to do performance testing in into two categories. We have the performance from a backend perspective, and then we also have the front end performance. Knowing the difference between these two types of categories is essential because it impacts your system differently. The type of test that you write is quite different, and also the type of metrics that you analyze is also very different. So the first half of the talk, I'll talk about the key differences between backend and front end performance testing, and the advantages and disadvantages of doing one over the other. And then the other half, I'll talk about why you need both to get a holistic view of your application's performance, and how do you adopt this hybrid approach. So with backend performance, typically, you target the underlying infrastructure of your application. So this could be, for example, testing a specific microservice, or it could be testing that, your database can, handle all the queries in a specific time, and that it returns the, response accordingly as to what is as to when is expected. Or it could just be an infrastructure that not necessarily exposed to your users. There are, of course, like different tools that you can use to get started with backend performance, but in general, a test script that checks the backend will look different from what a front end performance testing script looks like. So here I have a really simple example using K6, but the like format in terms of like how you do a backend testing script, that could vary like depending on the specific tool that you're using. But in this particular example, I'm just using K6, where you can see that I'm performing a get request to a URL, and then I'm just checking if the status code returns 200. Now, this is a very simplistic test, and in the real world, however, you might have like an example script that performs various HTTP GET requests or POST requests, and then you sort of configure different options on how many virtual users you want for your tests, and how many number of iterations that it should make. And you probably, are aware already that, when it comes to backend performance, the most common activity is doing load testing. So this is where you put a high demand on, your system, and then you measure the response time on different loads. Understanding the why though, so why we do load testing, why we have to do, why we have to expose our system on such high demands is actually important as well. So backend performance, it not only provides you insight as to what your application's latency is, or what your application's response times is, but it can also give you insights on different aspects of your application, such as the scalability of your system, like the availability, the elasticity as well, and your system's overall resilience to, like failures. So with backend performance, we're not just monitoring, let's say, what happens when, you expose your system in a particular load. We also have to look at like the overall, like aspects. So how scalable your application is, or how available is it, like depending on, let's say, if it's been exposed to like high number of load, is your system going to be always available as your users expect? And then from a backend perspective, there's also different load testing types that you can perform. And in order to have the most benefit out of your performance testing strategy, you need to be able to create a script with, not just with a set number of load, but you should also try and mimic different patterns of traffic, because this creates like different risk profiles for your application. So to get the most out of, performance testing, you should really use like different test types. And I'll quickly go over what these different test types are. So the first type of load testing is what we call smoke testing. So this might already be familiar, like to some of you, but from a load testing perspective, this is where you just verify that your system can handle the minimal load without any problems. So it's quite useful to run a smoke test script if you want to verify that your test script doesn't have errors, or you want to verify that your system still works as expected under a very minimal load. And then the one that I've explained already is, the load testing, or average load tests as well. So this basically checks how your application behaves if it's been exposed to, your normal and typical load. So it's useful in like situations where you just want to assess the performance of your application under like a typical load, and you can also identify areas of like degradation, especially during like the ramp up periods. Stress testing, so this is where you're trying to assess that a system performs at its limit when the load is above average. So this is where you're trying to, I guess, verify how your system behaves if your website has been exposed to higher than usual workload. So think of events like, if you have like, I guess, like deadlines for work that you have to submit a certain application at this time, or paydays as well. So that could create maybe like a higher traffic to a specific application. So you need to also run this particular test to make sure that your application can also handle above average like load. Within stress test, there is also another type of load test called spike testing. So this is where you're verifying whether the system can survive and it can perform under a sudden and massive rush of traffic. So this is very useful when your application might experience like sudden increase in traffic. So, for example, if we think of events such as Black Friday sales, where you're going to experience like a sudden income of traffic, then it's very useful to tailor your load test according to that. So in order to make sure that you can also handle like such extreme surge of traffic. And then finally, there's also soak testing. So soak testing, this is concerned with your system's reliability over a longer period of time. So it's quite normal for some systems to operate for such extensive like period of time. So if you want to test that your system doesn't really suffer from any memory leaks, and if you want to identify like any race condition, then doing soak testing can be really useful. So advantages. So many backend performance issues, it can spiral out of control, especially, if you're doing it like later in the development cycle. So an advantage of, backend performance, especially with the different load testing type, like, like doing like the smoke test, and, but with modern tools nowadays as well, is that it can be started earlier and it can be integrated during the development cycle. So this promotes that shift left approach to performance testing. Another advantage when it comes to backend performance testing is that it allows you to target, different components of your application. So you don't always have to, do end-to-end testing. You can independently test different API like endpoints, and then check if it can, accept like, like specific user flows when it comes to like the number of virtual users and the number of like iterations that each users can do. So you don't have to always do like an end-to-end approach. So you can start it earlier, while the development of the API is still happening. It's also less resource intensive, because we're just really sending a bunch of like protocol level requests, that you can easily ramp up. Because if we compare this, let's say, with a front end performance testing, we don't really have to spin up like a browser instance. We don't have to wait for like certain elements like to appear on a web page. So it's just really a matter of sending specific HTTP requests, and that is something that we can easily like ramp up because it's quite cheap to send. And then it also promotes this continuous testing approach. So especially, with the different types of load testing, so you can easily integrate, for example, like smoke testing as part of your continuous integration pipeline. And then, you can have like checks so that before you merge a pull request, it can quickly verify that, it can handle like the minimal load. And then it just promotes that culture of like continually testing the performance of your infrastructure. The limitations though, so backend performance testing, it won't really tell you anything about what's happening on the front end. So essentially, it's ignoring your user experience because it's only concerned on what's happening on the back end and not on the front end. A back-end performance, test, it would really just make the underlying request. But if there are certain, resource, or if there are certain elements that are taking a longer time to appear from the front end, then the back-end performance test won't really like check that. It's also much more, I guess, it could get quite lengthy to create. So especially if you're trying to mimic complex user flows. So when it comes to, front-end performance testing, we can argue that the scripts are, much more simpler to create because it's much more closer to the user experience. Whereas if we're trying to replicate that same user flow from the back end, then, you might end up with a really long script. And that also has this consequence that it could be quite difficult to maintain, especially as your website grows. Because from like a front-end perspective, we just need to, if there are any changes on like a specific user flow, like, there are certain practices out there that can help you create your front-end performance tests in a much robust manner. Whereas from the back end, we normally have to tweak a lot of the requests. Now, if I move on, so I've been talking about back-end performance testing. Now let's talk about what front-end performance is. So front-end performance testing, this verifies the user experience, at the browser level. So in here, we're actually trying to verify that a specific user, has access to a specific web application, and the experience like for them is not degraded. So for example, if they want to go to your website to fill in like a form, they can click specific buttons, and they would just have like a really great experience, and it will be fast like from their perspective. The metrics that we analyze for front end performance tests, it's typically quite different from the back end like performance testing as well. So from the front end perspective, the like the golden signals, if we like to call it, is really Google's Core Web Vitals. So the Core Web Vitals, these are like the standard de facto metrics when it comes to tracking the level of like user experience that your users experience. So it measures your users interactivity. It measures like the visual like stability of your pages, and of course like the loading time. Whereas from a backend perspective, the metrics are quite different, and so this is why you need to like consider like different approaches, because from a front end like performance, the metrics are tend to be different from what we see from the backend. Some example tools. So I haven't like really included, all the other tools, but one popular tool is Google Lighthouse, which is built in, as part of Chrome. So you can just easily check the Web Vitals, like easily. If you want to check what your real users are experiencing as well, because Lighthouse only uses lab data, which is data that's controlled from like specific environments. So if you really want to check what your real users are experiencing, there are other tools, but one really easy tool that you can use is Page Speed Insights. So you can just provide the URL, and then you can see all the different Web Vital metrics. But if you want a more, I guess if you want to measure like the user interaction, then you can also use like other tools. And one tool that I would like to show is this K6 browser. So it provides like a rough compatibility with Playwright API. So if you're already familiar, with Playwright, then K6 browser is something that can help. So you can see here that from a API perspective, it's quite like familiar. So we're just visiting a page, and then after that, a bunch of Web Vital metrics will be printed. To give you that like overview of like the different metrics that are important from a front end perspective. Advantages, so it measures the overall user experience. So you get view as to how fast a specific element has rendered. From a browser level, it measures if you have a lot of like visual shifts on your page. And because as testers as well, like some of you might be familiar with writing tests from a functional perspective, so it could be quite easier to write as well. And another advantage as well is it sort of supports this golden rule of web performance, where 80% of performance issues are found on the front end. So if we try and fix these front end performance issues first, then you can argue that you have fixed 80% of it, because that's where most of like the bottlenecks occur. Limitations. So front end performance, it doesn't really look under the hood. So it doesn't look at your underlying infrastructure, your databases. So again, it doesn't give you a holistic view. And without I guess load, so if you're just testing from a single user, it doesn't really test your performance under like realistic traffic conditions. And if you are doing browser level load testing, like where you're spinning up a bunch of browser views to mimic like different users, this can be quite resource intensive and costly. Finally, as well, another limitation is if you're only testing front-end performance, this can sometimes lead to misleading results, especially as you scale up. So whenever load increases, the response time from the front end remains fairly constant, but that's not really the case with the back end. So if your back end has been exposed to a lot of load, then like issues can quickly like scale up when it comes to, you know, backend issues. Whereas from a front end, it's just really going to impact like a single user. But once you know, you start to see bottlenecks from a backend performance, then, you know, 100, 1,000 users will both have some issues when it comes to like the performance of like what they're seeing as well from like the front end. So I'm not gonna talk about this hybrid. So I know this talk is about a hybrid approach, but this is the type of hybrid that I won't talk about instead. So I'll talk about, you know, this hybrid where it's a mixture of, you know, two other things. So from a performance perspective, a hybrid approach is really a mixture of both back end and front end performance. So, you know, you've both seen the disadvantages, the advantages of doing one over the other. So, a question that like you might have is which one should you use? And you should really do both, if you know possible, because they look at different parts of, you know, your application's performance. So doing both is really essential. And you know, one approach that, you know, we like really believe in is, you know, if you, let's say, you know, if you're testing like at a larger scale, so with like thousands of users, rather than, you know, having 1,000 users from like a front end like browser level, you know, why not keep the bulk of your traffic from a backend perspective? Because we have seen the advantages of, you know, doing you know, like a high level of load from a backend performance. It's less resource intensive, it's, you know, cheaper to run. But then at the same time, while the backend is being exposed to high number of loads, one sort of change that you can introduce is you can also run some front end performance checks simultaneously. So this could be, you know, using different tools like Lighthouse, you know, page speed insights, or if you're using frameworks like Cypress and Playwright, they can also integrate Lighthouse, you know, like libraries. So from the backend perspective, you know, you can continue to use like your favorite tools, but while that is being run, why not, you know, simultaneously check the front end as well to see how your user is getting impacted when the backend is being exposed to a high number of load. A common problem though, when you're doing this hybrid approach and if you're using different tools is, you know, is script duplication because of the differences in the two approaches. So here in K6, you know, we have created, you know, the same tool that can do both front end and back end. So this can definitely provide you with a simpler developer experience where you can just add or you can just update your existing protocol tests and then add browser tests on top of it. So how does that look? So again, this is with using K6. So in here, you can define different scenarios for your browser. So the first scenario has one browser virtual user, and then the second scenario has about 20 like protocol, or that could be like 100, like depending on like what sort of load testing type you are doing. And then you can just create, you know, different like functions for your browser. So the first one here is using K6 browser. And then the function for the protocol test is just using the standard K6 core. And what you'll end up with is an aggregated view of your application's like performance metrics, both from the backend as well as from the front end. So at least this simplifies, you know, this hybrid approach. If you want to see more of like a demo on how it works, again, I've added a QR code here that you can take a picture of. That should take you to my personal GitHub project, which shows how you can use K6 browser in much more detail. So just some final words. So front end and back end performance. you should really try and do both, because if you're only doing front end performance, let's say that, if the underlying application, so if your API is very fast to respond, but then from a front end, like you have like a huge picture. So for example, here I have our mascot, like Berta. So if that picture really takes too long to load, like too slow to load, then your users aren't going to like it. On the other hand, if your homepage is, quite fast to load, but then your application or your APIs or your databases hasn't really responded with the data that the browser needs, then again, your users aren't going to like it. So whichever tool you end up using, testing both front-end and back-end performance really gives you that holistic view of how your application really performs. So ideally, you should do both. So yeah, that's all from me today. And if there are any questions, I'd be happy to take them.